Find the cubic expansion of the square root of 1 plus x over 1 minus x and state the range of values of x for which this expansion is valid. Okay, we can use the binomial theorem to actually expand this. If we write it down and then put these in index form, this will become it's the square root of 1 plus x over the square root of 1 minus x. So that will be 1 plus x to the power of a half divided by 1 minus x to the power of a half. And then we can make this one up here by making this minus a half. So we get 1 plus x to the half times 1 minus x to the minus half. And now we can use the binomial theorem to actually expand these. So the binomial theorem says 1 plus x to the n is equal to 1 plus nx plus n minus 1 over 2 factorial x squared, n minus 1, n minus 2 over 3 factorial x cubed, and so on. So expanding each one by one. So in the first case, we'll take x is equivalent to x, n is a half. So that will become 1 plus a half x plus a half times minus a half over 2 factorial x squared. You take 1 away from n each time. Plus a half times minus a half times minus 3 over 2 over 3 factorial x cubed. Simplifying that, where it becomes 1 plus a half x, and then we can work this out on a calculator. It'll just give you minus 1/8 x squared plus 1/16 when you work all this out x cubed, and then obviously the next term will be minus, but we only need to do up to x to the power of 3. Okay, doing the other one, this time you take x equivalent to minus x and n is equal to minus a half. That will become 1 plus minus a half times minus x. Make sure you're using brackets here. Plus minus a half, taking another 1 from that will give you minus 3 over 2 over 2 factorial times minus x all squared. Plus minus a half times minus 3 over 2 minus 5 over 3 over 3 factorial minus x cubed. And that will give you 1 plus, because minus times a minus a half x, plus 3 over 8x squared, plus 5 over 16x cubed when you work these out. You can use a calculator to work these out. Just use the fraction button carefully on your calculator. Right, we need to go back and do the multiplication. So that means we'll need to take the first one here, which we wrote on the other side, times this. And we will ignore any term that is greater than x cubes. Right, so first one will be 1 times all of this, so that will give 1 plus a half x plus 3/8 x squared plus 5/16 x cubed. Then we do a half x times 1, which gives me a half x. A half x times a half x gives me a quarter x squared. Then a half x times 3/8 x squared, which will give me 3/16 x cubed. We don't need to do the last one because that will give it an x to the fourth term, and we're not required to do that. So then we got minus 1/8 times 1, minus 1/8 x squared times 1 would give me minus 1/8 x squared. And then minus 1/8 x squared times a half x will give minus 1/16 x cubed. We don't need to go any further. And then there will just be 1/16 times x cubed. Anything else will give me bigger than x cubed. Right, so the single term will be 1. Then we've got a half plus a half x, which will become x. We've got 3/8 of x squared, 1/4 of x squared, and minus 1/8 of x squared, which together will give me 1/2 of x squared. And then these two obviously cancel out, so we've got 5/16 plus 3/16, which gives me 8/16, which is 1/2 of x cubed. And then the expansion stops there. Because both the expansions were valid from minus 1 to 1, then the whole expansion will just be valid for the absolute value of x is less than 1, or x being between minus 1 and 1. So this has been a video to show you how to find the binomial function of a square root by splitting it up and then using the binomial theorem for a negative index. I hope you've understood, and I a negative and a fractional index, sorry. I hope you've understood, and I thank you very much for watching.